Chess is one of the most popular games in history. It also has very long traditions than we think. Chess was invented in India around the 6th century, but its name was Chaturanga at the time. Sesa, an ancient Indian minister, invented Chaturanga and showed it to the king of India. He was quite satisfied, so that he really wanted to make amends for the game. Sesa required a simple wish. First, put a grain of wheat on the first space of the chessboard. Next, put 2 grains of wheat on the second space, which is twice as much amount as the first. And then 4 grains of wheat on the third space, 8 grains on the fourth, and so on. Sesa wanted the sum of all those grains wishes on the board. What a small wish for the king! But can it be so? We need to know some mathematical concepts to answer this easy-looking problem. Let me show you these random series of numbers. Can you find certain rules from this array? The answer is, numbers are twice from the previous numbers. 2 multiplied 2 is 4, 4 multiplied 2 is 8, and 8 multiplied 2 is 16. So now on, let's call this kind of array geometric sequences. To know about geometric sequences, there are needs for understanding initial value and common ratio. The initial value is literally the first number from the geometric sequences, which is also referred as the mother of all subsequent numbers. Going back to the arrays right before, 2 is initial number. Then, what is common ratio? Common ratio is a constant number in the geometric sequence which multiplies previous number, and in the previous example, it would be 2. So, geometric sequence is made up of common ratio and initial number. It grows into a tremendous number even we couldn't imagine. For example, how long will it be if we fold newspapers 50 times? If we fold newspaper once, twice, and 3 times ahead, every time a newspaper size will double. Finally, the thickness of the newspaper will soar. Likewise, bacteria grows exponentially. There is also a formula for the sum of these sequences, and we call this series. The sum of geometric sequence appears this equation through this process. Let's go back to the wheat and chessboard problem. According to a geometric series, we can now easily calculate the whole amount of the wheat grains. The number of grains increases to 1, 2, 4, 8, until we arrive at the 64th space. We know that its initial value is 1 and common ratio is 2, so its sum appears as this formula. It seems like it is quite a big number. Surprisingly, the result of this formula is 1844674407370955115. Phew, it looks even disgusting, isn't it? The entire weight of the wheat is 1,199 billion, which is about 1,645 times the global production of wheat in a year. Eventually, we got one clear conclusion. The king must be needed a pocket to go out begging.